right, this is Miss Schultz. So I'm gonna do some examples, 2 examples, specifically this one and then a word problem. After this, I'm gonna do this word problem of separable differential equations. All right, so I'm gonna do it based on steps. And so my first step is to separate the variables. So I'm gonna multiply by dx on both sides. I'm gonna do another step simultaneously. So I do sort of 2 steps in one. I see that to get my x's on the right, I multiply by dx on both sides. I want my y's on the left. So if I divide by y squared, that will get my y's on the left. So that cancels and that cancels. So on the left, I have dy over y squared. And on the right, I have 4x dx. Okay, so that's my step 1 of separating my variables. Step 2 is to integrate both sides. I don't have the directions listed here, but the directions are find the equation for y. And that's why I want to integrate, because I have the derivative, and to go from dy dx to y, that's an antiderivative. And so integration is part of it. So I'm going to integrate dy over y squared equals the integral of 4x dx. Now the right, not that hard of an integral. The integral of 4x is 2x squared. On the left, I need to rewrite this first. So I'm going to rewrite this. Actually, I'll do this in a... that's fine. I could have kept this as an integral and done it in the next step. That's fine though. So I need to rewrite this first. Rewrite. So think about how to rewrite this integral. It would be y to the negative 2 dy. Keep the integral in front of it because you haven't integrated yet. You've just done some pre-calc algebra manipulations. You haven't actually done calculus between this step and the other step. You haven't integrated. Now I'm going to actually integrate or anti-differentiate. And so I'm going to add 1 to the exponent, y to the negative 1, and I divide by the coefficient by negative 1. I'm going to simplify this. Okay, so I get negative 1 over y equals 2x squared plus c. Okay, so in terms of my steps, they're listed here. So I separated my variables, I integrated, check. Next step is to solve for the c. So let's do that. This is my initial condition. I annotate it. And so I'm going to sub in 0 for x and 1 for y. X isn't always 0, but it has been in these problems. Negative 1 over 1 equals 2 times 0 squared plus c. So c is negative 1. Okay, now I'm going to do my 4th step, which is to sub the c back in. Okay, so I'm going to substitute it in right here to the most recent form of my equation. Okay. Now I just have one more step, which is to solve for y. So I'm going to multiply both sides by a negative, or just flip the signs of everything. So it becomes 1 over y equals negative 2x squared plus 1. Okay. And now to get just y, I take the reciprocal of both sides, but I have to do it as follows. I can't take the reciprocal of each and every term individually with a plus in between. I have to think of like all of this is over 1 and do 1 over negative 2x squared plus 1. Okay, so again, you can't do what would be wrong, would be say like negative 1 over negative 2x squared plus 1, like 1 over 1. That would be a big no. Don't do that. Don't take the reciprocal of each term. Take the reciprocal of everything. And the reason why is when you take the reciprocal, you're basically raising both sides to the negative 1. In this, exponents do not distribute over addition. They don't work that way. Multiplication distributes, okay? But exponents, you can't do that. I mean, just think of like 5 plus 2 squared is not equal to 5 squared plus 2 squared. This would be 49, yes, which is not, you know, 29. Okay, so exponents don't distribute, so you just need to raise the whole thing to the -1. You flip the whole thing. Okay, and this is my final answer. All right, so that's that. Let's do our last example, which is a word problem. Okay, this is very AP style. I modeled this after a release question, actually. Okay, first of all, we notice that we're not going to use dy and dx. It's going to have dh and dt. All right, let's read. We have this little image down here of bamboo. And this is true. These are based on real facts that I Googled. Hopefully they're right. Anyway, bamboo is the fastest growing plant on Earth. For the first 2 weeks of growth, for t less than 14, right, because there's 14 days in 2 weeks, a model, so t is going to be in days, a model for the height of the bamboo at time t days, it tells us, is the function h. So h stands for the height, okay, and t is in days, okay. Okay. A model for the height of the bamboo at time t days is the function h that satisfies the differential equation dh dt equals the square root of h minus 10. After just 1 day, the plant is 35 inches tall, for real, according to Google. So h of 1 equals 35. This is going to be my initial condition. Initial condition. I'm going to use my initial condition to plug in for my plus c. I'll use it in the middle of the problem. Okay, find an expression for h of t. That's my first question, or, you know, thing I have to do. Based on this model, what is the height of the bamboo after 7 days at time t equals 7? All right, so let's copy over this. dh dt equals root h minus 10. Okay, so I'm going to follow my steps. Step 1 is separate the variables. Okay, I'm just writing it pretty lightly because, you know, I don't know, I'm just writing my steps lightly on the side. So I want my h, think about if h is like y or x, and if t is like y or x. Okay, h is like y, t is like x, so I want my h's on the left, like I normally want my y's on the left. And I want my t's on the right, like I normally want my x's on the right. So I'm going to multiply by dt. So I get dh equals root h minus 10 dt. All right. Now, these variables, I haven't separated my variables. I have an h and a t on the right. That's a problem. I'm going to divide by root h minus 10 on both sides. Okay, so I have now separated my variables. dh over root h minus 10 equals dt. Okay, so think about the next step. Now I want to find h of t. So I have dh, so to go from dh to h, I want to anti-differentiate. That's my next step. I'm going to write the word integrate. Really, I'm just going to write int. Okay. So I'm just going to write it as the integral of dh over root h minus 10 equals the integral of dt. I'm going to rewrite this in order to integrate. So think about how to rewrite this. So I'm going to have h minus 10 to the negative half dh equals, and I don't need to rewrite I just need to copy it over basically. Okay? This is negative because it was in the denominator. It's a half because of the square root. All right, now I'm going to integrate. So I add 1 to the exponent. H minus 10, negative a half plus 1 is a half. I multiply by the reciprocal of my new exponent, I get 2. I have a linear inside, so based on the chain rule / u substitution, I need to divide by the derivative of the inside. The derivative of the inside is 1, so I'm good. this is done. The integral of dt is t. Say that again. The integral of dt is t. If it was, say, the integral of, like, just on the side here, if you had to integrate like 5 dt, sometimes this is so simple that people are like, well, I don't know how to do it. This is 5t, okay? So if it has a dt, it integrates to t. And then the coefficient just stays. Here, the coefficient was 1, the invisible one, so it just stayed there. Okay, so I'm still in my integration step, but I'm going through rewrite, integrate, and now I'm going to simplify. Okay, so I know 2 h minus 10 to the half. I'm going to rewrite this as 2 root h minus 10 equals t plus c. Now I'm going to do step 3, which is solve for the c. I'm going to, in order to do that, I sub in my initial condition. So this is my independent variable here, which in this problem is t. It's my dependent or output or dependent variable. This is going to be h. So I'm going to sub in 1 for t, 35 for h, and solve for the plus c. So let's do that. 2 root 35 minus 10 equals 1 plus c. So I get 2 root 25 equals 1 plus c. I get 2 times 5, which is 10. Subtract 1 from both sides, and I get c equals 9. At this point, if you get a perfect square underneath the square root, you should say, I'm probably doing something right. Probably. Okay, so this is my c. My step 4 is, so we'll just say this is like find c, and this is sub in c, okay? So right here is what I'm gonna sub into. Right before I plugged in my initial condition, that's what I put my c back into. So 2 root h minus 10 equals t plus 9, like that. So I'm right here, and I need to solve for my h, or get h alone. So I'm going to start by dividing by 2 on both sides. This cancels, so I simply get root h minus 10 equals, and I'm just going to keep this as t plus 9 all over 2. I could make it t over 2 plus 9 over 2, but I'm not going to. Now I square both sides. So I get h minus 10 equals, again, I can just keep all this together. No reason to FOIL it out, just double distribute, just, you know, I would just leave it like that. There's no incentive not to. And then I have h equals, it's asking for h of t, so at this point, I'm just going to write it nice h of t. So I have t plus 9 over 2 squared plus 10. All right, and that's the answer to my first question. Find an expression for h of t. This is it. So big picture, what did we do? We were given an expression for the rate. This is in inches per day. Okay, this is useful to know, you know, sure, it grows by this many inches per day. A square root function rises quicker and then rises by less and less. So my bamboo grows a lot at the beginning and then less and less over time. That's what it's saying. Now, a lot of times though, you don't want to know the rate. You want to know, like, okay, after a week, how high is the bamboo? You know what I mean? Like, what's the height after a week? That's the actual, I want to know input a time and get out a height. That's what we want to know. And that's what we just figured out the equation for. I can now input a time and find the height, as opposed to just like knowing a growth rate. So let's do that. At time t equals 7, so based on this model, what is the height of the bamboo after 7 days? So I'm just going to copy my expression over that I found. H of t equals t plus 9 over 2 squared plus 10. You don't have to copy it. But now I'm going to sub in 7. T of 7 equals 7 plus 9 over 2 squared plus 10. Okay. So let's evaluate. 7 plus 9 is 16. I'll just write it all out. Why skip any steps? Okay, I'm still going to skip a step. 16 divided by 2 is 8. 8 squared is 64. So plus 10 is 74. Whoa. So after 7 days, the bamboo stalk, the bamboo, will be 74, think about the units, inches tall. Whoa. Okay, we don't need that. So yeah, this is just an example of a Diff EQ that's very AP style. And there you go. Thank you. Bye-bye.